Hello everyone, my name is Draconicrose and welcome back to Wild True Learn. This game has been on the channel before, obviously, but it had so many frequent updates that I often had to restart it. So I decided to stop covering it until it was at a more stable release. Well, now that time has come. The game is complete and it's currently on the process of being ported to the Switch even. You can tell there have been a bunch of improvements, so for example, the main menu now has music. Hooray! Not silent anymore. There's a lot of good things to explore, but for now we are just going to start a new game. To become a programmer, you must master your art of turning the computer on. Press and hold the flashing triangle and drag to connect the power outlet. When done, press the power button. And congratulations, you're almost a programmer. Okay, so it wants us to turn on the computer, so you can tell things have changed. And we turn the computer to the monitor, the computer to the keyboard, and now we turn the power on. Hooray! So that's interesting. A fun way to show the game mechanics where you connect things to things and then things move through the connections. And there we go. Now, do you have a story of some sort now? Bugs. Coffee. Tired. Kitty. More coffee. Kitty goes in. Kitty fixes the bug. Ah, build successful. Ah, what a good kitty. Can my cats do that? Meow. Hey, what did you do? Did you do that? Holy zeros, if only I could understand what this cat has to say. I guess we'll have to find out a way to recognize your speech. Goal, cat speech recognition to-do list. Google it on Cat Overflow. Ah. Enter your nickname. And that would be Draconicrose. How to recognize animal speech. Hey everyone, can you believe my cat, that little devil, has debugged my code? Again, he definitely has something to say. So I decided to make some sort of a system, algorithm, which would help me understand him, give me advice, wish me luck maybe. P.S. I'm not insane, my mom had me tested. Oh dear. And someone replies, don't rush ahead of yourself. Making a device that would be able to detect the cat would be a nice start. You can work with video, sounds, etc. when the time is right. Hey, a couple of days ago I've been reading about how expert system can be applied for detecting animals and writing chatbots. I can see the English grammar of this game has not improved that much. The newspaper was called Deep News. I'll be sending you my copies once I'm done with them. And as you can see, this start is already much better than what it used to be. Welcome to your workspace. This is where programming magic and bugs, mostly bugs, is born. To begin, drag an expert system node from the list on the right. Drag the connection from the starting node to the thingy, and then do the whole connections. Click test run. And it definitely should work more or less correctly. Now we do have the speed settings, which I will keep on max. There you go, run complete, success, final result, a medal. Okay, so what's next? Hey again, I've tried that expert system and it hardly makes sense. Squares are floating from left to right. Is that what the fuss is all about, machine learning? Are you guys actually working there? This is called visual programming, my fellow dude. Yes, this is how it's supposed to work. The expert system analyzes your data input from the camera and checks if there's a cat on them. No, it's not what machine learning is all about. We'll get hardcore soon enough. But I'm not very good at it yet. Apparently, when do I start to actually building a cat translator? Don't rush it, friend. You gotta master the machine learning ninja skills first. I'm working as a freelancer and the amount of contracts is crazy. I'll forward you some jobs I don't have time for. It'll help you get on your feet. And earn some cat bucks as well. Check your mail now. P.S. You're still paying for the servers though, yeah. Alright, legit. Hey Draconicrose, noob advice. There's an auto-help for each new technology. Very convenient. I've turned it on for you now, no need to thank me, but you probably want to change your password. My cat talks 123 is pretty obvious. Okay. Behold the task tree. This is the map of your progression in the game. So vertical progression for story, horizontal for extras. Icon colors stand for different types of machine learning technologies used in respective tasks. Sounds simple, or so we hope. So first task, applicants. Good day, we're from a public school. Summer exams have ended, the results are on the letter. Could you process them and tell us which students will enter the MIT? Alright, so pretty easy. You get expert system. You do the connect. Alright, so we want the green, else, yeah, test run. Bloop, 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 bloop. And that should be enough. Pretty easy. Alright, release to complete, and there we go. We got 350 cat bugs. The cloud was 42, so 308 total. Continuing. Hello, we have some errors in our questionnaire data. We can't solve the problem. Can you please fix it? Your efficiency is measured not just in money, but with medals too. Medals influence your story progression while boosting your self-esteem at the same time. To get a medal, your scheme has to meet the respective time and nodes limits. You can improve your result later on. So now we have the trash can to destroy elements. No matter how many trash cans you place, they'll count for one node in the nodes limit. Okay, that's good. Real datasets have a lot of errors. Filtering out errors is a very important skill for all data scientists. I have actually done this in real life, but we used a program to do it visually. Alright, so in our case, we are going to want a trash can and two expert systems, actually. So if it's red, we want it to continue. If it's green, we also want it to continue. Or not, wait. So if it's blue, we want to trash it. If not, we want it to continue. So actually I don't need this node. How do I delete the node again? Delete. Okay. Pretty easy. Okay, let's just get that done. And there we go. Sometimes I will over-engineer some of these solutions. Just don't mind me. Alright, so there we go. Lunch complete. We got the goal, I suppose. So that's fine by me. I will accept your money. Errors 2. New types of errors, and we need to update our previous program. Dip news. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces decisions of a real person. An example, this is Eliza, the very first chatbot in the world. It was created in 1966 and talked with the patient using questions similar to a real psychotherapist. It worked horribly. Yeah, it did. Just Wikipedia Eliza and you'll see how bad it was. Custom nodes tab is where you can find nodes composed from your previously created algorithms. Feel free to reuse them in your other tasks. Feel free to edit your custom schemes at any time. Simply double-click the right mouse button on them or use the down arrow button on the node. So, guess we're going to want this red else, so if it's red, go out, else bash it. I mean, that seems pretty good. There we go. Gold medal, 2 out of 2. Perfect. What's next? Decision trees. Oh, we get a little pin note as we go. So let's take a look. How to recognize a cat in the picture. Finding a cat in the picture. Hey, is there any way to detect the cat without using expert systems? It works for text, but with pictures, not so much. Furthermore, the cat just won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. This little devil is way more effective with pictures. Also works nicely when paired with other algorithms. Or you can use nails or glue or something. Come on, it's just a cat, it won't fight you back. I'm joking, please don't use anything I mentioned on an actual cat. Yes, do not. The cat would not like it, and you would be very, very injured. Different nodes have different processing rates. This parameter will influence the efficacy of your schemes. Icons on the right indicate the amount of time required for a node to process one element of data, so that's a few seconds. So, in the game, this node compares output parameters, the sockets, with an element's color. If the element's color is equal to only one socket's color, the element moves to that socket. If an element's color satisfies both conditions, or none of them, it goes to a random socket. In the real world, a decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar to the element. And you can see there's a tree structure behind here. I can tell you from my classes that we did map out these trees, but we also used programs to create the rules and map them out. We didn't actually program them, but that could be an interesting thing to test out. Alright, so what do we want? Well, we want to make sure that we filter these things. So how many? One node. Ooh. Okay, so we do the decision tree. And if it's red, go up. If it's... okay, I get it. If it's blue, go down. The green will not match any, and it will go both ways. So that should be what we get. Yeah, exactly. So that was a pretty easy tutorial. Decision tree equals smart tree. We're not going to go with the optionals right now. Maybe at the end of the main task tree. Illuminati Origins. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati secret society. I need to recognize all the triangular shapes in these documents to solve the puzzle. Could you design a program that would do that for me? Right, speed, and we are getting the sift node. This node compares shapes. If an element's shape matches the designated shape, said element goes into the top, else to the bottom. In the real world, SIFT, Scale Invariant Feature Transformation, is one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. SIFT is very fast and is capable of recognizing simple objects and patterns. Never use this. Ever. But it wants us to use two nodes, so I'm guessing this one and the trash can, so triangle goes up, everything else in the trash, and we run it. And there we go, we are within the gold stuff. It was a pretty big amount of money. Working for the man feels too easy, boring, or soul-sucking? Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. But we are not going to do that. We are going to continue. You have reached the end of the epoch. Click one of the banners to proceed further into the story. Oh, so we need to probably do the other ones to keep going through gold. So let's go through silver. So he buys a box, a camera. Okay, this should work. And it almost did. Almost. So didn't work. The cat has been detected is our next part. Animal emotions recognition. Hey, so I managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go next level and start recognizing emotions. Have you heard of Perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, lava lamps. Also, you can maybe switch to dogs instead of cats. Decision trees work like a magic for my Pluto. You can also hit the store and get that random forest block. A forest is more effective than just one tree, you know. Alright, and now for something completely different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. The percentage of errors is shown on this icon. Use training mode to teach Perceptrons and decrease the amount of errors. In the game, in training mode, Perceptron reduces the amount of errors while trying to predict the shape of elements. In the test run, the Perceptron only predicts shapes. In the real world, Rosenblatt's Perceptron used in Mark I. This Perceptron could recognize only simple, linear dependencies, but it was enough to recognize English letters. And of course, you know, you can go learn more about it. So, in this one, we need a single Perceptron, and we just need to easily connect it, right? And we need to do training mode, so let's do that. Let's reduce the errors to an acceptable rate. I wonder how low it can go. The blocks on the field have reached their minimum margin of error. There's nothing more you can teach them. Oh, wait, so let's go. Alright, this run is the actual test run for delivery. And we should be gold. Alright, so either way, we have two ways to go up, so RL0, I do not want that just because of the things. Let's go back to the tree. Let's do text recognition. Be aware that you are able to create a text recognition system based on the Rosenblatt Perceptron. We need a similar system that would also be able to distinguish vowels from consonants. This task is simpler, but more accuracy is required. Alright, so the Rosenblatt Perceptron. First Perceptron was invented by Frank Rosenblatt in 1957. Frank created the Mark I in 1960. The Mark I is a perception machine that can recognize English letters by their shapes. Alright, we have one. Again, it's basically the same thing. Can we connect two nodes to one? Yes, we can. Oh, but we cannot do this. That is interesting, but this one needs more, so we'll send the triangles there and do some training. There we go. Test run and deliver. I wasn't actually paying attention to how things were getting up here, so let's hope they were. Okay, so we're green on both, and that's enough for gold, and there we go. So, parallel calculations. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? To process data, your nodes need computing power, a server. Certain nodes require more than one server. The more servers you use, the more expensive the scheme becomes. In the game, this node routes elements to the least overloaded socket. In the real world, a load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases the availability of applications. So basically, any big app or website you use now uses load balancing. Mostly the website, especially YouTube. When you actually upload a video to YouTube, what happens is that YouTube actually copies the video to several different servers and distributes them across the world. So when you need a video, it depends on where in the world you are, which version you are going to get. should always be the same version of the video, but you know. And that is also how they can do the whole "this video is blocked in X region" thing. So the more you know. Large parallel calculations. Hey, our parallelization system broke after the last Doors OS upgrade. Can you fix it? It's a very big system. Be careful. The darkest years of machine learning. In 1969, Seymour Papert and Marvin Liebinsky wrote a book called Perceptrons. In this book, they spoke about math constraints of the first perceptrons, the XOR problem. This book has shifted the scientific interest and funds distribution from the US government organizations, slowing down the progression of machine learning for almost 30 years. The expanded version of the book was released in 1987, containing chapters that disprove the statements from the critical remarks made since 1969. Alright, again, load balancer, 3 nodes. Okay, so we want this. There we go. So we balance to each of those. Each of those balances to one output. And that is good. Whee! Okay, very good. Dictatorship. Best dictator in the world at cat.meow. Greetings, this is the only state internet provider of a small country. We have a rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code, but we have several new services purchased on the garage sale. Parallel the calculations, this will help our tyranny prosper. Don't do that. That is, you know, immoral. These are Github repositories. They store previously made schemes and allow switching between them when required. You can choose a version of the scheme which will be used as a custom node. So yeah, this is the thing. I'm not sure if this will become useful in the future. We have a DLL as an editor. 8 nodes. Ooh. 30 for the bronze. Okay. Only are parallel. So we definitely need red expert systems and a few balancers. So I'm thinking 4 of these, right? And 3 of these. We only need 1 trash can though. Put it on here. So things will go in the balancer, which will go to the other 2, which will go to the 4 there. There we go. And then if it's red, it's going to the output. If it is not, well, you actually don't need these. Let's delete those because we have only red node. We just need a few of these, okay? So, I mean, basically the same number, but we can dispense with the trash can. Okay, that's not gonna do anything because I forgot to connect the outputs. Always double check your code. So it should be good, so the balancers will keep things going there, and the only reds... Ooh, that might be a little slow, might... no, it was okay. There we go. Right, so that was fine. We'll accept. Can you rate the game? Feedbacks are important and empower cats. Due to all of the, you know, grammar errors and stuff, I'll rate a 4. 4 out of 5 is tremendous, thank you. But would you maybe share your thoughts on what we need to get that one last star that got away? Yeah, no. So, prediction of elections. Electrons? Good morning. We are contacting you on behalf of Yahoo's Corp. The president of our partner venture has been dismissed last month, and the board of directors is in the process of electing a new one. We need to be able to predict who will win the election, so we could make a decision about the future of our partnership with said venture. Make it happen, you'll get a handsome reward. Use Ctrl-C to copy, Ctrl-V to paste. Click, hold and drag mouse, select multiple nodes. Programming is easy, sometimes at least. So why? We just need red. Red and blue tree divide, 2 parallel. Why can't I use my my only red here? That sucks. So we have a large input stream. Well, this does only do the thing. So let's go back to our thing and actually do the 4 parallel even, because that only gets read out. So yeah, maybe. Okay, nope. Why? It takes input. Oh, and only spits out. Okay, no, I get it. So it doesn't matter which ones it has there. We still need to sort only the red, so we don't need this one. 7 nodes. Red, blue, tree divide. Okay, I could see that. Let's use a 2 parallel. And use the red tree divide, and then use the decision tree color to send reds down and blues to the trash. So that's okay, and we should be able to copy and paste the nodes with their connections, which is great. And do I want another load balancer here? Or maybe I just want 2 of them. Well, let's see how it goes with 2 of them. And then we'll see. And I want this red to go down here. Alright, so the solution is surprisingly simple. Like I said, I tend to over-engineer things. You just get 4 trees and you separate the most different ones, so red and blue. So the blues go immediately to the trash can, and then you separate the reds from the greens, and they go over here. You use a load balancer to move them, because the decision trees are way faster than load balancers, and you only need the 1. I actually managed gold with 6 out of 7 nodes. So that is our final result. And also the end of the episode. So if you enjoyed it, please don't forget to subscribe and check out my Patreon, because it is the way I can do this and my job, and you should pay me. No, I'm kidding. You should become a patron if you would like to support the channel. But until next time, please remember that here there be dragons.
Thank you so much to my patrons for making this channel possible. Click the Patreon logo to become one of these fine folk, and if you enjoyed the video, here are some more YouTube things you would like. Don't forget to like this video and subscribe. Have a lovely day, and I'll see you next time.